The artificial intelligence is one of the critical and emerging technologies that we've heard about it highlighted in that national standard strategy that's been mentioned a few times over the past couple days. The next topic, Mosa standards, has been a focus of several National Defense Authorization Acts in recent years. And for that next panel, I'd like to welcome Ms. Nadine Geyer.
As was just mentioned, my name is Nadine Geyer. I'm with the Office of Undersecretary, Research and Engineering, the Systems Engineering and Architecture Group. My title is Systems Engineering Director. My responsibilities are threefold. One is the Systems Engineering Modernization Program. The second responsibility I have, and they're not in priority order, they're all important, is the Fundamental Systems Engineering Research Center. And then the third area of responsibility is Mosa. I am going to assume that most of you know what Mosa is, but for those who don't, let me just give a brief explanation. It stands for Modular Open Systems Architecture, or I'm sorry, used to stand for architecture, says it's most modular systems approaches now, open approaches. And basically what it is a viewpoint in the government that we don't need to own every aspect of a system. So traditionally, programs in the DoD, we go to a big vendor, especially the larger programs, go to a big vendor like Lockheed Martin, General Dynamics, insert a name here of a company, and we say, we need a missile, we need a system that does X, Y, and Z, and we let them develop it along with all the subcomponents. And then every time we need to upgrade that system, every time we need to make a change to that system, we have to go back to the original vendor and say, we need the following upgrades. They have to agree with that, and then they institute those upgrades. To give you a real life example, because I used to be in the robotics world, we used to work with companies to do ground robotic systems. They had all the IP rights to those ground robotic systems because we needed to put them out there fast because we had gone to war in Iraq and Afghanistan. So they were sole vendors and they had all the proprietary information. We wanted to put new camera systems on those. Those cameras cost about $260 a piece. The company said, fine, we will put the cameras on your robotic systems. It's going to cost $300 per system to put it on for the integration. These cameras were literally plug and play. So double the cost of what those cameras cost to integrate it into the system. We want to get away from that. Mosa components and Mosa design involves taking your system and subdividing into reasonable components based on whether you think that that component in the future is going to be taken out to be repaired or replaced, or because of mission changes, you're going to need to change it out. Making those components modular, going to possibly smaller vendors and saying, I need a sensor system that does X, Y, and Z, and that fits in this face but had this kind of interfaces. We don't care what's inside your box. As long as it performs and fits the interface criteria and does the best job, we're going to use it and then integrate it into the system. And what this does for us is allows us to get past that vendor lock, so to reduce costs, and it allows us to be able to quickly change out components in the sustainment phase. I don't know if most people are aware, but there is estimated in the government that the sustainment phase of any project is about 70% of the cost of that project. And when you're talking about systems in the DoD that cost billions of dollars, that is a significant portion of money that we could be saving when we do a modular approach. I like to think of Mosa as an enabler. So Mosa basically, I'm going to ask you, what are you trying to, just like AI when he was saying, what are you trying to accomplish? What are you trying to accomplish with Mosa? Are you trying to get past vendor lock? Are you trying to replace components quickly? Are you trying to get a reusability between, say, airplanes? You all want to use the same landing gear, so you don't have to develop that component again. So you use every single one of them, they make it modular, so every single type of airplane can use the same landing gear or the same wing substitute component in there. What are you trying to accomplish? And usually Mosa will help you get there. Now, in the DoD, there's also not just a push on getting systems more Mosa, there's also a push on getting systems more interoperable. You don't want to be going into a battlefield space where your components are not working well with one another between the Navy, the Army, the Air Force, the Marines. You want them to be interoperable with one another. The way you get to interoperability partially is through standards. Usually open-based, consensus-based standards. That does not get you a complete solution in interoperability, but it gets you a long ways along that path. And that's why we're all here today, is to talk about standards and the importance with our programs. A little bit about myself. I have over 30 years of experience in various programs. I started out with launching systems and working in shipyards, to working on nuclear programs, to working on missiles, and also I've done work in ground robotics and EOD systems. And most of my work had been with the Navy, but I have worked with the Air Force, the Marines, and the Army with their programs as well. And so I've introduced myself, I introduced the topic. I'm going to let each of the panel members introduce themselves and give a little bit about their take on standards and what they're doing within their organizations on that.
Can you all hear me? Oh, awesome. So my name is Hema Manavanan. I am the Modular Open Systems Approach Lead here at DSPO. So I lead our Mosa standards efforts and also chair the MOSWIC Standards Tiger Team, which is a joint service working group that falls under the greater umbrella of the Modular Open Systems Working Group that Nadine leads. And basically we're working on issues related to standards and specifications, but related to MOSA. Aside from that, I work in digital standardization as well, and with the ASSIST database and its much needed modernization. And just prior experience in this space, I've been in MOSA for a little bit. I know a good amount of you sitting here. I used to sit at Army headquarters as their MOSA technical SME, and just providing policy and guidance, working ITRAs as well with the ACAT-1 programs, and providing program support for MOSA in particular. Priorities for DSPO, Mr. Sims kind of went into this in his keynote yesterday, but just to dive a little bit deeper, we are curating this MOSA enabling standards portfolio within the ASSIST database, and it will serve as the authoritative source for both government and industry to see what standards are being utilized for MOSA implementation throughout the services. And so this effort has DepSecDef visibility. You know, we're regularly reporting to Nadine's team and up to Honorable Ms. Shu on our progress on this effort. So we're slowly making progress, but definitely moving in the right direction there. And just to talk about more, you know, what we're doing with this portfolio, we obviously have the MOS standardization area within the ASSIST database, which is the Modular Open System Standards and Specifications area targeted for MOSA. And we have one MVP right now with 3 admin notices for each of the services, Navy, Army, Air Force, dictating what standards, fall under Mosa implementation through each of the services. In this next instantiation of the MVP, we're looking to expand scope and really looking at the current landscape and seeing that a lot of things have changed in this space, as you'll hear from Christine and Cliff as well from the respective services. The standards have matured and evolved over time, and it doesn't make sense for us to keep these admin notices when we have efforts to, fold them into the DSP framework accordingly. So that's adoption notices, that's, mil spec, mil standard transition if it's appropriate to do so. But we've also been seeing this growing rise and trend of these quote unquote like non-traditional standards bodies that are being developed within the government space, where they're government-led, government-managed efforts, essentially creating these ad hoc working groups where they're bringing together industry participation. They, have consensus base, and they abide by all the other principles that are dictated in the SD9, right? For, what non-government standards bodies do, or non-government standard bodies similar to consortia do. But they're being developed kind of ad hoc, for agile development of standards. And so recognizing that this is a growing trend, right? We've had the DSP for over 70 years. We want to make sure that we're also evolving policy and procedure to better support what's changing. And so we have, in the latest revision of our manual, dropped in some language that allows for the extension of those adoption notices beyond industry-led consortia and NGS to some of these government-led efforts as well, which has been a great success because it allows us to fold in a lot of these existing efforts in the Mosa space pretty easily, right? We're not trying to make it difficult to comply with the DSP. We do want to make it so that everyone can reap the benefits, but in a way that's less burdensome. So within this portfolio as well, we're also working on the tagging of standards in the assist database. So kind of the distinction that we have is that the MOS standardization areas for those Mosa unique standards, right? FACE and SOSA, Victory, Mora, kind of those, they've been developed over the years specific to Mosa, but there are other standards out there that are being used to enable Mosa, and they're in other technical domains. And so we want to be able to tag those standards in the assist database so that when you see the portfolio, you can see the ones that are unique and also the ones that enable. And so that tagging effort also, kind of pulls me into the MOSWIC standards Tiger team stuff as well, where I'm leading this Tiger team to define refined criteria for what's considered to be, a truly Mosa enabling standard. And then using that criteria, those refined definitions to then further validate and tag standards, both current and going into the future. So that's just a little bit of what we're doing here at DSPO.
All right. Oh, good. It's always concerning when you're in front of a group of people and then they give you something very simple. You push a button and it should work, and then it doesn't work. Yeah, it always makes you feel like, oh. Well, so my name's Christine Moulton. I'm from the U.S. Army's PEO IEWNS. So we're the Intel Electronic Warfare and Sensors Program Executive Office. I am the director of our integration directorate. So I report directly to our PEO, General Barker. And I have really 4 areas of efforts that I look into at the integration directorate. About 2 years ago, the acquisition, ASALT came down and said that all the PEOs in the Army should make integration directorates. And from that guidance, each PEO now has their own integration directorate. And we, of course, talk amongst the other PEO integration directorates. But our main focuses are, how do we take our individual PEOs, provide interoperability, the MOSA principles to our PMs, and then also work the integrations not only internally to our systems, but externally to other Army PEOs, but joint as well. And so within PEO-IWNS, our integration directorate really focuses on how do we implement standards and architectures? How do we provide more feedback from the actual operational soldiers and users of our systems? Because a lot of what, I'm sure many of the folks in this room know is, we have great plans. We have everything that we've thought. We've got all our I's dotted, our T's crossed. We're ready to go. And then our systems go to the soldiers. They start getting dirty and, things change just by the nature of, what our capabilities support. And so we're really trying to increase the feedback we get from the units to understand the context of our sensors and our sensor data. And that's kind of been a common theme that I've heard, is basically understanding not only what our systems are doing and what these standards are enabling, but how they're being used. At the end of the day, we're trying to make our operators more effective and more lethal on the battlefield. And how do we take feedback from the units and translate that into updated requirements? How do we translate that into better understanding of our interoperability and our sensor data, and really start to bring that whole piece back together? And then we also run for PEO our digital engineering ecosystem effort. So really trying to bring the PMs, everything that was talked about this morning basically is what we are working on to bring the PEO over. We have a unique problem set within PEO-IWNS, really because our portfolio spans not only simple, cheap, kind of unattended ground sensors, UGS, or even force protection systems, but we span the gambit basically from that force protection to cyber, to EW, to space. We have air platforms and air sensors as well, and we do a lot of work with the larger intel community as a whole as well. So our portfolio itself is very diverse as far as capability, sensors, platforms that we work across. And so our PMs feel the pressure of having to be compliant with multiple standards very, very much and every day. We had one program of record that had to maintain 195 individual integrations for standards in order to be compliant with its requirements. It's unsustainable. From a software perspective, it becomes a behemoth. It's very complicated. You change one thing, and as we all know with software, I have 195 other things that are also dependent on that one change. And so sustainability-wise, it becomes impossible to do it affordably and appropriately for the systems, and to be able to change as we have the rapidly changing times. So within PEO-IWNS, we have our enterprise architecture work. We're taking in all of the architectures that are from the unified mission threads those mission threads are what the Army interoperability certification uses basically for its backbone of, are you compliant? There's a lot of changes with AIC moving forward, but it's a place to start as far as the Army's historical account of what are these systems supposed to do as far as what we have on paper. And then we take also the programs that we have in development, and we're basically building them into a model-based system engineering, what I'm calling an enterprise architecture. It's a little E, but really looking at PEO-IWNS's architecture and systems. What are our information exchange requirements between our systems and others? Where are their dependencies? Where are their non-reciprocal requirements? Because we might have a requirement for A to talk to B, but B not to talk back to A. And so inherently, that's not going to work once we get to the field. The requirements need to be updated to account for that. But also what we're using the enterprise architecture to do is to understand historically what standards have we used and get down to exactly how it was implemented. So not saying we used VMF, but we used this version of VMF, this message, this series, and this was the information that we provided. And this is what it meant. And now we're building that up so we can understand what standards do we use, where do we need to find improvements, and can we use other standards to start really narrowing down the portfolio of what we have to support. And also have reuse. common APIs that are developed to make certain integrations or implementations happen can now be reused across the PEO. Maybe I start now from a 70% solution from zero, what we had before. And so building out that enterprise architecture, is really key for us understanding the landscape of just what are our systems doing and where, at what echelon, at what security domain, all these things. So we have within the integration directorate, we also manage what is called the integrated sensor architecture. So it's ISA. It started out of the Army's common operating environment, which started about 12 years ago. And I have a chart that basically shows what you can visualize as a ball of yarn and just all kinds of connections made. And at the time that COE started, that was a visual representation of all the point-to-point connections that we used within the Army to share data. And the problem is, while all those connections use standards, they were mostly proprietary. And most of the time, we kind of abuse the standard. So you kind of get to the place where I'm real world, things are happening. The standard doesn't meet my need. I can't go to the standards body to get it changed. There's not enough time. So you improvise, right? You duct tape it and you do the best you can. And so that means that we, shoved extra information into the sensor, but we have gentlemen's agreements. So if we agreed, no problem, but nobody else is going to be able to come in and be able to be a part of our gentleman's agreement, right? So we don't end up with that dynamic nature, which as we move forward and really look to how we're going to be fighting in the future, it's dynamic, it's degraded. Our networks are really, really, really poor. We have limited bandwidth, especially in the Army. If you look company and below, there's not a lot of space. There's voice, there's PLI data, and then there's sensor data. All three of those things have to work across the same network band that's the size of a soda straw. So it's really important for us to be able to dynamically understand the data, dynamically send the important information, and be able to triage the information that needs to be sent. If I can get one bit of data across the network, what is that one bit of data, right? And that's where we have the integrated sensor architecture. So it comes out of the sensor CE requirement, which is a AROC approved document that goes back to the joint requirements that says, look, we need to create a sensor data interoperability that provides dynamic discovery of systems and system capabilities that works across any modality. So not just radar focused, not just intel focused, but how do I make it so that these systems on the surface share information when you don't really think they do normally. And so we created the integrated sensor architecture to do that, of basically defining the data model such that we have expanded it over the years. We have quite a bit of adoption, kind of falling into that government-run standards group that Hema was describing, where we have government-owned, working with our ABCANS partners, providing input into the standard, input into the APIs, the SDK as well, keeping it completely releasable. So as far as the standard goes, any of the SDK, API documentation, and compliance tools, there is a definition for compliance. And there is only one way to do everything in the standard. It may not be the best way for your system, but there's one way. And really starting to pull that thread and using it to cross the boundaries of these systems. And, it is being used within PEO-IWNS and our PEO-IWNS systems, but also jointly with other services. And then also, with our ABCANS partners and, their standards bodies as well. So, that's really my focus from PEO-IWNS, really looking at how do we take these standards and how do we implement them. And, we aren't trying to be the one standard that rules them all with ISA, but we're trying to be an equalizer. When we have multiple systems that have to speak 4 or 5 standards, can we make it so ISA can be the common interface that we use for the plug and play and dynamic discoverability, and have done the work beforehand so that the seamless transition between the two standards work. So Could be ISA to JICD for the Intel folks. It could be to CMOS, which is another one that's used prevalently also within PEO-IWNS. It really could be any of the other standards, but how do we make it so at the end of the day, our PMs don't have to manage multiple interfaces. We have an easy way to describe it and then be able to share the information across.
Hi, everyone. Unfortunately, Mr. Randy Machado from the Space Force wasn't able to join us today, so I'm kind of sitting in instead. My name is Cliff Loudon, the DEPSO for the Air Force, but also the Mosa PEM. And I'll come back to why that's great in just a minute. So just quick background on myself. Studied mechanical aerospace engineering, systems engineering. First big boy job was at the patent office. So I have appreciation for IP and the procedure that goes along with law. I've worked with F-35, so I appreciate the joint aspect. Worked submarine safety, so I appreciate the quality assurance aspect. And so as I find myself, one more thing. At F-35, I also learned a little bit about standing up maintenance, especially for software, is insane. That 50-50 split it's atrocious. Trying to sort that out. But as I find myself in the position as both PIM for Mosa and DEPSO, this is perfect. This is exactly where I want to be because, share a secret, I want a Voltron robot before I die. And yes, that's a pie in the sky hope and dream, but there's only one way to get there. And that's through the acquisition process, the congressional, PPBE process, and the technical, requirements to make it happen. And so I'm happy to be where I am at the SAF-AQ, where I think I can affect that sort of change. Not the end result, but at least I know where I'm aiming, and working with colleagues who have similar dreams in mind, I think we can do it. So that's I think all I wanted to share for the opening, at least.
It's a generational thing. I want a Star Trek world. I really want to have the majority of the questions come from you guys because I really want to talk about what your concerns are and what your questions are. But I am going to start off with one question up here while you think about what questions you want to ask us. So I'd like the panel to talk about how you see the standards organizations or standards changing based upon the new digital engineering world.
Sorry. So for us, with the movement into digital engineering, really being able to understand the interfaces that our systems currently use and really being able to use that model-based approach and linking it back to requirements. I would say that right now is kind of the biggest change for us because it's enabling us to, one, have a common implementation, common set of data that all the PMs are providing, but also be able to give us a holistic picture of what have we done in the past and how have we done it.
Yeah, I'd like to echo what Christine said and just add on the idea that standards development, right, in a digital world, standards development isn't changing, right? The processes are all the same. We're still going to be developing standards. It's the tools, the ecosystem that we're using that, result from digital engineering that are going to impact the how, but the actual standards development will stay stagnant. And that's one of our guiding principles within our digital standards strategy is that, as we're building standards in this digital world, in model-based environments, it's still going to have the same rigor and trust that standards today have, within the Word and PDF construct. That's not changing.
Right. Yeah, exactly. I think the discipline of engineering doesn't change just because it's digital. You know, you don't become a better, you don't learn systems engineering by being handed MBSE tools. You have to have that knowledge to use the tools well. Sure, you can learn systems engineering in part by using the tools, but to understand it, one comes before the other, right? So, like Hema was saying, like the standards themselves, the way we go and develop standards, that's I think the same as it ever was. We're using a different ecosystem to do it in, and that's going to improve the consistency, the accuracy, the outreach, and the interoperability because of the nature of these tools. It's going to make everything easier, but standards development's not going to change from a philosophical point of view, I think.
Yeah, I think what I was getting at with that question is that I believe that the standards are going to be developed the same, but how they're utilized is going to change in the digital world. Modeling and simulation programs are going to start taking those standards and put them as an integral part of the modeling and simulation world, so that it will automatically pop up and help inform the design decisions for systems engineers.
That's exactly what I hope to see. Like, I hope that a junior engineer can, let's say, remote into the master computer, and we're all using that same kind of ecosystem. But because they're working missiles, they can say, oh, I want a fresh sheet. I'm going to download a missile template, and that program will kind of pre-populate certain standards, maybe not all the standards, but certain standards, maybe even certain GRAs to get them started. Just like we open up like a template in Word for a resume or something. But that, times 1,000. That's kind of where I hope to see it go. But that's maybe just how I see it in my mind. And I think we're at such an early stage where maybe all of us are kind of imagining different things.
Yeah, I think that what we expect from systems engineers or electrical engineers or mechanical engineers sometimes is a little more than what they can provide in this day and age. They're expected to understand manufacturing. They're expected to understand all the different standards out there. They're expected to understand the impact of electrical systems on mechanical systems. They're expected to understand all the interfaces. And I think that it's very easy to lose track of an element of that when you're doing a design process that's going to affect you later. And the digital engineering tools, although they won't make you a better systems engineer or a better electrical engineer, can help prod you in the right direction so that you don't forget about an aspect or critical aspect that you need to think about during the design process. And certainly AI, as they just talked about earlier, can help with that as well, to help move us along in the design world where you don't get to the end of the project and said, I forgot it has to fit in this space and I've made it too big, or something along that line. So that's where I think we're hopefully going in the future. But I wanted to leave plenty of time for questions from the audience. I have other questions if you don't have any, but please go ahead. Yes.
So if AI works out well and it helps us design, develop everything, how does the output of that work in terms of deciding whether it's suitable for public release, whether it even is so smart it generates classified data on its own? Who figures that out, and what kind of network are we running it on? Over.
We don't have the AI experts up here, I think. But it's a very good question, because there is a concern in the DoD part of what kind of, not just are the answers or the results of the AI accurate, and truthful, because we've known AI to develop answers that are not truthful, and that has to be verified. But will it actually create things that then become classified or actually lead to an unintended consequence that we hadn't anticipated? There's a lot of work in that area right now. I don't think I have the answers. I don't know if you guys are more familiar with that.
Not, we're running into this problem now, not just from the AI perspective, but it comes the same as we have more interoperability of our systems, and we're kind of using our systems in that MDO approach, the modernization plan and strategy that was put out by the Army. A lot of questions are coming up even with us, you know, as I'm having my EW sensor, which may be unclassified, connect in and start sharing data with the ChemBios or start sharing data with our mounted mission command systems. At what point does discovering all of that data and information take it to the next step? And historically, as security classification guides are written, it's not been a focus, right? It's very, we've always designed our systems. It is a box, it is a widget, and I'm making this system. And we've, in the Army and in the DoD with all of the new Mosa and the modernization approaches, which are all great, it's really turning that on its head and saying, okay, we're not building a box that it's an island anymore. It's now a box and a system that shares data, that relies on others, that I'm now finding new capabilities to use to execute my mission because I can dynamically find them. And so even not from an AI perspective, but we're struggling with that within the PEO and within the Army. And it's something that Mr. Garciga at the CIO's office is, you know, really starting to work through. Is, you know, at what point does the data aggregate and become more than it once was? I can have a bunch of cheap unclassified sensors, but I put some more data on it and they're not really unclassified information anymore. And so I don't think even within the Army, definitely not within PEO, IWNS, we have the answer to that, but it is a problem that we're starting to think about. And it's going to have to be a change with policy. And it's going to be a different way to write security classification guides than we've had before.
Doesn't it take an original classification authority to make that determination?
Well, you kind of asked maybe 5 different questions in the one question, right? So you're asking about certification of AI, basically, like, do we believe it, right? So the amount of V&V that has to go to that is one question. Another is the cybersecurity. Another is the security, right? So, you know, who's the authority for that? Maybe AI will one day be the authority for that. Who knows? But where we are now, I think we could start using standards to maybe help get to those answers, separate answers, a little bit quicker and more accurately, because we can use tools to make sure that we bounce it off every other existing policy that exists. But we're going to have to go around, you know, that carousel several times before we can even answer those questions. So I think that whatever you would come up with to answer the question is probably similar to what we would come up with to answer those questions. It's like, well, we gotta get with the different experts. We got to go around and we got to play the game. I don't think that game is going to change per se, just where we do it and how fast we can do it.
So I'll throw in real quick. We have done an SCG for an AI model, right? And had to send it up and get it approved and all. But really that was just focused on saying that the output wasn't any more classified than the aggregation of the data. But we deal with it all the time as well, where we're aggregating massive amounts of data. And the answer is there is no one answer. It's you have to work with the data owners, and every bit of data we add is a conversation about which line that pushes it over. And we've had conversations, okay, if you're gonna bring that data in, you got to pull out this bit of data, or you got to omit that, or whatever. And so it's just it's going to be a conversation. I don't think there's a one size fits all answer there.
Yeah, I think that one's kind of it's a matter of trust, right? So to go through and analyze, you know, a data lake and say that, oh, it's at the same classification, that, okay, maybe that's the case, but somebody made that determination that they believe that is at that level and enough authority behind that opinion that other people are like, okay, I can believe that. So I think we have more human factors decisions to kind of come up with, and that's where the standards come in, right? To go forward with it. And it's exciting to see, but I wish I could tell you I knew what we're going to do, but I think maybe that Navy approach will, if everybody's going to give it a shot, and then we'll choose the winner. So that'd be good.
Are there any? Yes, sir.
So Bruce Burnside, NAFC. A question as far as your recommendations on how to address MOSA from a high ontology level to the low ontology level. So for example, you have a lot of great policy guidance out there. How do you get the worker bee to actually do MOSA, do it right, not going off in like 10 different directions?
Well, to put a plug in, we're putting out a MOSA guidebook, and it should be out this month, by the end of this month. It's in the signature cycle right now to help with that. It's not 100% solution. It's like an 80%, but we wanted to get the information we had to date out there as soon as possible. And we're going to immediately go into a update cycle. And we're probably going to be doing that for a little bit until we get it down to a better, the best process that we can. Incentivizing people to do MOSA in an environment where some program managers think that it adds additional risk to the program is a difficult problem that we are trying to resolve with the various services. And that's why we have a MOSWIG that meets on a regular basis so that we can talk about it and try to resolve these issues with them and try to get people to do it. I'll tell you this, and I've been honest with other groups with this, MOSA is probably not going to save the program money when it's first implemented in the program. So during the design phase, it's probably not going to get that system out quicker. It's probably not going to get it out cheaper, because there is a learning curve associated with this that is going to have to be worked through as people learn how to do this process. Where you're really going to see the savings in time and money is in the sustainment phase of the program. When you're able to swap components out easier, when you're able to take your system and repurpose it to do a new mission, that is when you have an obsolescence issue where a component you needed to switch out because of that, that's where you're going to see the savings, because it's going to be much easier not just to switch out that component, but also to perform the testing associated with that, because that's going to be smaller because it is its own component. And also the software upgrades associated with it should also be easier to perform. But here's the kicker: the sustainment phase saves you costs on average each program about 70% of the cost of that total program. And that's why I was mentioning that earlier, is because that is where you're going to see the bulk of your savings. So you're actually going to save the government or the DoD a lot of money in the sustainment phase that can be then used to develop new things later on. But unfortunately, program managers are incentivized to get that stuff out there as soon as possible and as cheap as possible. And so trying to convince them that they need to look at the sustainment phase as well is a difficult and a culture change for them. And we are working on that through a training process. We are working on that by going to these conferences and talking to people. We are working on it by working with each individual services to get the pressure put on to be able to convince them that this is the right thing to do. Does anyone have any?
Yeah, I'd like to piggyback on what Nadine was talking about as well. If you're using cost as your initial driver for doing MOSA, you're probably not going to see the benefit of cost savings for quite a long time, or it may not at all, right? Because a lot of the tenants involved with MOSA allow you to have technology upgradability, refresh. And so you may avoid cost, related to maintenance and all of those exterior complementary areas, but you're still going to have incurred costs from the item itself that you're having to replenish over the 5, 10, 15-year cycle. And then I wanted to touch on a point too that I think you had briefly mentioned, Bruce, about like kind of like the higher to lower ontologies and related to standards, at least, right? We're, of course, building out this portfolio with that listing of most enabling standards. But one of the key ideas that's been brought up within the MOSWIC Standards Tiger team is that's great, but now how do we establish those linkages between the standards, right? We don't want to lose, how the standards are being implemented and, within the domain, how they're being utilized, because interoperability also resides with how you use the standards, right? You have commonality in what standards you're using, but also how you're choosing to tailor them appropriately. And so that's something that we're going to have to work on and continue to workshop within this Tiger team so that we can implement those ideas within the portfolio and try to tailor accordingly within the Assist database as well.
I'll add on, just from being my PM's favorite person, as the one who's come down and had to implement MOSA and grade them on their compliance to MOSA. Probably not everyone's favorite person, but what we have found, at least from the implementation, is, of course, it's a cultural change of how they've done it in the past, but we've actually seen, from PEO IWNS perspective, we wrote a very detailed implementation plan that laid out very clearly what the PM's responsibilities were and what the PEO headquarters responsibilities were as far as MOSA goes. What does MOSA mean for PEO, i.e. WNS, right? And we have such a diverse portfolio, that was pretty large definition, right? Because it changes depending on the system. And one of the things that we've set up is we have our implementation plan. We do host training for our engineers. We have subject matter experts that are available to help at the beginning of their system engineering process. When a new requirement drops hot off the presses, the integration director is there to help from, hey, this is the enterprise architecture that we have. Historically, this is how we've done what these requirements are. But we also help them as we develop RFPs and RFIs by looking at their system and the components of their requirements. And before we do anything, taking an analytical look at what are the possible MOSA boundaries, right? Because at the end of the day, I don't really care how your sensor does it. I just care that the data it's producing can be found, right? And what we've seen, at least with a couple of programs we've done this with, we've been able to write very defined governance acceptance tests. So instead of saying, hey, be unicorn standard compliant, and the prime comes and they're unicorn standard compliant, but all they did was put out their position in unicorn standard. Everything else is proprietary. That's a common thing that you see a lot with the implementation. So they follow the letter of the law and not the spirit of the law. And so what we've been able to do is say, hey, use the ISA standard, use JICD, whatever is appropriate after we've done kind of the decomposition of requirements, which the PM shop does anyways when they get a new requirements document. And we're able to say, look, we want you to use this standard, but explicitly, I need this information from the standard, and this is how you're going to do it. So we have seen improvements from that side of the house of we get RFPs back, we get responses back from industry that have fully thought out the interface that we want them to make. I'm not saying we've done it perfectly every time. It's been a learning process. But we've also seen where we can have smaller businesses propose a very tiny portion of our system of system, right? I mean, if you think of some of the intelligence platforms, they have different levels that they serve, right? And, at the highest level, it's got a lot of components. It has a lot of capability. It does a lot of stuff. And what we've been able to do is say, hey, we've broken the system out into these compartmentalized pieces. And the small business who has this capability, all you have to do to be competitive and to meet that need is to follow the directions and put your data out in the standard, and it'll work with everybody else that's already making up my system of systems. And so from PEO-IWNet's perspective, that's how we've implemented it. And honestly, the PMs, cost, schedule, performance, 100% their goal, right? Which makes sense. That's what we tell them to do in the 5,000 series, right? But as we've been working through helping them understand how to define standards to get what they want the first time, it slowly changed them over to understand kind of the usefulness of thinking through your interfaces, taking a little bit of extra time, which may be a month, maybe only a couple weeks, and then the product you receive back is so much better. And you open up the ability for competition, especially for some of these really niche things that some of these small businesses do really well. So from our side, I think over the last 2 years, that's been the shift. Initially, they gave us the Heisman. They didn't want to do it. But as we've worked with them and as we've gotten some of these prototyping efforts back, and these pain points that have always been pain points aren't those anymore because of the work we did on the front end. I think we're just slowly, turning them into believers, at least from kind of our implementation side of the house.
Yeah. So part of the question I think was how do we grow those junior engineers, right? So I think partly with the help of like the ubiquity of programming and computer science in general for the younger generation, that lends itself to Mosa way of thinking. And so by encouraging the behavior that we want to see in them, maybe not calling it Mosa, maybe encouraging, hey, we want your thing to be able to work with another thing. We want your code to be clear and reproducible. We want your data exchanges to be more compatible with other things along the tech stack, right? So by encouraging those things, after a while, they kind of develop those Mosa habits. And then maybe later on, we can say, hey, don't look now, but you are doing Mosa because you go to that way of thinking first. You think about what can I do to make my design more compatible? What standards do I need to do that sort of thing. So I think that's kind of how I would approach it anyway, of how I want to grow junior engineers by, having them think the way we want them to think, or at least guide them along that path, and then maybe they'll even surprise us, which would be even better.
Yeah, we're getting into your break time here, but just to be clear, I said earlier, you're probably not going to save money in the development phase. You will if you reuse components from other programs. And there have been very successful programs out there that have reused components from other programs that have shortened their development time because they no longer had to develop those components. They were able to reuse them, and then they could concentrate just on the new components, which saved time in not just development, but in the testing cycle. So I'm sorry, we're over into your break, and we'll stop here.
Thank you. It was great discussion.